Welcome back, class. With this video, we're going to begin our study of Chapter 17, which is a continuation of our look at equilibrium in chemical reactions, but specifically, we're going to be exploring equilibrium as part of acid-base chemistry. So there'll be a lot of discussion of different types of acid-base concepts, but tied in with the idea of equilibrium around them. So let's start with just a little survey of acids and bases. So we'll start with acids. So on the table here, you can see some common acids, many of which you've probably heard of, and some of their applications. And while I don't want to necessarily get into any specific applications of any specific ones, I will point out a couple of them, a couple of uses that I think are more important, or sort of things that we should just kind of know. First of all, hydrochloric acid, right? This is the primary component of stomach acid. The sulfuric acid, this is the acid that we find in your classic automobile battery, what we refer to as battery acid. Acetic acid, which is the main component of vinegar. Citric acid, you're probably familiar with as the acid that is present in citrus fruits, like lemon, limes, oranges, etc. Carbonic acid, right, is the acid that forms when we dissolve CO2 in water, right? So that carbonated beverages will contain carbonic acid. Now, of course, there are other acids, and a few of them are listed here, but there are many, many more acids. Now, if we look at more general overview, acids, at least the ones that we should consume, will tend to have a sour taste to them. And you may have noticed this when you've drinking beverages that have an acidic component. They tend to have a sour sort of bite to them. Now, a lot of times things that we think about having a lot of acid, like, oranges and soda, different things, that sourness is masked by sugars, that sweetness. But sometimes, depending on, the flavor we're going for, right, we get that tartness that's associated with the acid. Another sort of well-known or sort of hallmark property of acids is their ability to dissolve, or what we think of as corroding, many metals, right? So metals will react with acids to, quote, dissolve. Now, chemically speaking, we should start to understand what we mean by dissolve is that we're converting the metal atoms into metal ions, and those ions are soluble. They have, of course, the ability to, quote, neutralize a base, and we'll get into the idea of neutralization and what that means a little bit later. And they react with indicators to change their color. So a famous indicator is litmus, right? And litmus paper will turn red in the presence of acid, right? So this is one example of an indicator, which is simply a material that will change colors in the presence of acid or base. So that's a general overview. Let's look at 3 different types of acids. So the first one, and again, these are going to be based on structural components, is what's called a binary acid. And a binary acid is simply made up of hydrogen, or hydrogen ions, we tend to associate them with, and some non-metal atom like chloride, chlorine, or fluorine, or bromine, or some other non-metal atom. So things like HCl, HF, etc. And many of these are familiar to us as hydrochloric acid, hydrofluoric acid, etc. So 2 parts hydrogen ion, and nonmetal ion. We have what are called oxyacids, and as the name implies, these acids contain oxygen. Now, another way to look at these structures is that we have hydrogen ions attached to what we commonly know as polyatomic ions, or oxygen-containing polyatomic ions, like nitrate and sulfate. And the acid part of those becomes sulfuric acid, right, which you can see as the sulfate ion, SO4 2-, with 2 hydrogens. And we have nitric acid, right, which is the nitrate NO3- 1 ion associated with a hydrogen ion. Right? And we can see those hydrogen ions right here and here and here, right? And these are the hydrogens that we'll talk about being lost in the presence of, when these acids are in solution. So we got binary and oxy. The third type of acids is what we call a carboxylic acid. And these are acids that are found in nature typically. Most of oxyacids, binary acids, these are acids that are not found in living beings, right, or plants or animals, right? Those are typically carboxylic acids. And what sets a carboxylic acid aside is its presence of this carboxylic acid group, right? Sometimes called a COOH group. We can see the more detailed structure here, where we can see it's a hydrogen, oxygen, a carbon, so an OH on a carbon, and then an oxygen double bond. And all carboxylic acids will have at least one of these carboxylic groups. A couple examples of this. This one is sort of one of the simplest, and this is acetic acid, which we said is the ingredient in vinegar. This is citric acid, right, which we can see pictured here, right, which is present in our citrus fruit. And another example over here is malic acid, which is present in other fruits and vegetables. And there's many, many, many of these, and you're familiar with some of these, like lactic acid, etc. Right? So there's a whole bunch of these organic acids that have this carboxylic group. Now, something to point out with these is that some of the hydrogens in here are not what we call acidic hydrogens, and so we will point out which ones, and we try to make them fairly straightforward. And when we draw the formula, typically the hydrogens at the beginning of the formula are what we call the acidic hydrogens. And these are the hydrogens, again, that will be lost potentially when we dissolve these materials in water or they undergo reactions. So we can turn our attention now to bases. So bases, unlike acids, have a bitter taste, right? So we don't eat a lot of bases, but things that do have a basic component, like coffee, has some base compounds in it, like caffeine is a base. And these, in part, will give coffee sort of its bitter taste, or some coffees a more bitter taste. Now, bases are also referred to as alkaline. That's another term we use for bases. And a certain category of bases are called alkaloids, and these are bases that are found in plants. Many of these are poisonous, and if they're not strictly poisonous, they taste very, very bitter, right? And again, often used as defense mechanisms by these plants to keep animals from eating them. Some other general properties of bases, right? They have a slimy or slippery feel when wet. Think of soap, right? Soap has basic compounds in it which give it the sliminess. Again, they'll react with indicators. So whereas acids turned red, turn litmus paper red, bases will turn it blue, right? So they'll react with indicators. And again, they have the ability to neutralize acids, just as acids have the ability to neutralize bases. Now, again, if we look at some common bases, either in the picture or in the table here, we can see there's a couple of different types of bases. We have what are called metal hydroxide bases, okay? And these are things like these, which are going to be a metal associated with a OH ion or a hydroxide ion. So like sodium hydroxide, potassium hydroxide, and used all kinds of industries. We have what are known as carbonate and bicarbonate bases, which, as the name implies, contain carbonate or bicarbonate ions, so such as baking soda, sodium bicarbonate, or sodium carbonate. And we have nitrogen bases, which are going to be part of a large family of bases that contain a nitrogen, ammonia being the simplest of the nitrogen bases. Now, there are many of these nitrogen bases, and some of them are well-known compounds that you're familiar with that fall into this category, such as, I mentioned, caffeine, nicotine, morphine, right? These are all fall under this category of nitrogen bases. 3 of those, right, are plant-derived, right? And would be what we call alkaloids. Now, one of the things that those 3 things have in common is that they are harmful, right? They are maybe not be poisonous, but they do have negative effects typically on the body, especially if used in excess. Now, sometimes those effects when used in low doses can be quite, useful, if you will, like with caffeine or nicotine. They have a pleasure response, if you will, in the body. And so we have metal hydroxides. We have carbonate and bicarbonate, and we have nitrogen bases. So those are sort of 3 basic categories of bases. So that's sort of a general overview. In the next little section, we're going to talk about some acid-base definitions.